Hi, in this video we are going to see about a Python IEEE project which is entitled as Electric Vehicle EV Price Prediction Using Machine Learning, which is an enhancement of IEEE base paper title Analysis and Prediction of Electric Vehicle Costs, a machine learning based approach, which is an IEEE 2024 conference paper. So before seeing the execution of the project, let me brief about this project. So we all know about the advantages of using the electric vehicles because those are protecting the environment and they're also lowering the carbon emissions. But still, any product or device, their widespread adoption mainly depends upon their cost factor. So in this base paper, the authors have implemented the machine learning approach for predicting the electric vehicle cost. So many works have not been done based on the electric vehicle cost prediction. In this base paper, the authors have used 5 different machine learning models. So here you can see that 5 supervised machine learning algorithms. They have used linear regression, SVM, ANN, decision tree and random forest are used. But kindly note that we are not going to use the same as mentioned in the base paper. So now let us see what we have done enhancement from the base paper. So first thing, we have introduced 2 different models from the existing system and we have made the proposed system using the gradient boosting regressor and Extratree regressor. So the first model, using the gradient boosting regressor, we have achieved training set mean absolute error as 0.1917 and test set mean absolute error as 1.4731. And the second model, using the Extratree regressor, we have achieved training set mean absolute error as 0.000 and test set mean absolute error as 1.6941. So this is about the model that we have used. So now coming to the data set part. So here you can see the data set that we have used to train the project, which contains around 103 data set records and it has around 14 features. The features are like brand, model, acceleration, top speed, kilometer, efficiency, fast charging, rapid charge, powertrain, plug type, body style, segment, seeds and price in the euros. So here brand is like the who's the manufacturer and what is the model here. Acceleration is the acceleration speed and top speed of the particular vehicle and what is the range for the kilometer range, how much it will be going for per particular charge and what is the efficiency here you can see. And here you can see about the fast charging, how much fast charging is made for the kilometer and rapid charge is available or not for the particular device. And powertrain, you can see AWD, RWD or FWD like that. So AWD means all wheel drive and RWD means rear wheel drive, FWD means front wheel drive. And here you can see about the plug type. So what is the plug type of type 2 CCS or type 2 CHA demo? So such kinds of plug types available. Those features are being given here according to the particular model. And you can see about the body style, whether it is a sedan, hatchback or liftback, SUV kinds of thing. Then you can see the segment is like market segment. So there will be different market segments like A, B, C, D according to the people's lifestyle. So that segment is being described, and seats, how many seats the particular vehicle has and what is the price in euro. So these are all about the data set part. So coming to the project, here you can see about the IEEE base paper abstract. Like coming to our proposed abstract, as mentioned, we are going to develop the electric vehicle price prediction using machine learning, where we are going to use Python as the backend coding language and we are going to use Flask web framework using the HTML, CSS and the JavaScript in the front end part. So as mentioned, we are going to use two robust regression model, that is gradient boosting regressor and Extratree regressor, and their performance evaluation metrics have been described in abstract part, and these are the 14 features which I have mentioned that is being listed, summarized in the abstract part, and this is about the proposed abstract. And coming to the existing system, so we are going to consider the base paper as the existing system. So in the base paper, they have employed 5 machine learning models like linear regression, support vector, artificial neural network, decision tree, and the random forest. So those details have been described elaborately in the existing system part, and it was observed that in the training phase, linear regression demonstrated the fastest processing time, making it most efficient model in terms of computation speed. The SVM and random forest algorithm exhibited nearly identical training times, reflecting their comparable complexity and structure. In contrast, ANN model requires significantly more time to train, which indicates that it is have the intensive computational demands. So here in the existing system part, you can see about the complete details of the existing system. And next, coming to the disadvantages of the existing system, so we are listed about the disadvantages of the existing system. And coming to the proposed system, here we can see about the proposed system model, which uses the two key regression model, gradient boosting regressor and Extratree regressor details. Those details have been elaborated with their performance evaluation parameter and the features, their data set details, and everything is being summarized in the proposed system part. And coming to the advantages of proposed system, so here listed about the various advantages of using our proposed system model. So those been summarized in this part. And coming to the system architecture, you can see we are going to give the input as electric vehicle data set, and pre-processing feature selection is made, and we are going to apply gradient boosting regressor and Extratree regressor, and the predicted result will be EV price in euros, and we will be showing the performance analysis and the graph parts. And next part is the system requirements, which contains the hardware requirements and the software requirements. So this project can be executed in Windows 10 or 11. So coding language we have used is Python 3.12.0. Web framework is Flask. Front-end part contains HTML, CSS, and JavaScript. This is the reference of the IEEE base paper. So these are all about the basic things of the project. Now let us see the execution of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of the Python and the libraries installed in it. So now inside the source code folder, we have this EV price prediction. Inside that, just click in the address bar CMD and click enter. So automatically the command prompt window open with the exact location of it. Now type python app.py and click enter, and kindly wait for a few seconds. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, paste it and click enter. So now you can see the home screen or welcome screen of the project with the project title, electric vehicle EV price prediction using machine learning. So just click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the login button. So now you can see the login success message and click OK. So now it will be navigated to the upload part where we need to upload the data set. So just select this choose file option. So inside the EV price prediction, you will be having the upload.csv file. Just select this file and then click this upload button. So now it will be navigated to the preview part where you can preview the data set that we have applied. So you can see the features, whatever we have shown you, the original data set, the same is being loaded into the browser part of it. So you can scroll down and see the complete data set has been loaded into the preview part. So if you scroll down till the end of the page, you can find this click to train or test button. Just click this and kindly wait for a few seconds. So So now you can see the training finish message and click OK. So now it will be navigated to the important part of the project, that is the prediction part. So here we'll be making the price prediction using the features that is given. So now let me show you the thing by entering the details one by one. So for the first case, let me enter the brand. If you click this brand, you can see what are all the brands that is available, like Tesla, Volkswagen, Polestar, BMW, Honda, Lucid, Audi, Nissan, Hyundai, MG. So all the details have been, brands are being listed out here. For the first case, let me give Volkswagen, and here you can see the model, what are all the models of the particular brand, everything is being listed out here. So now for this case, I'll just give model as ID3 pure, and here you need to give the acceleration in seconds. So for this model, I'll just give 10. Top speed is 160 and the range in kilometer is 270. Efficiency is 167. Fast charging is 250 kilometers per hour. Rapid charge is available, yes or no? Yes, for this model it is available. And powertrain, it is RWD, that is rear wheel device. Plug type that is used is type 2 CCS, and body style that is used here is hatchback. The segment of this segment for this type vehicle is C type segment, and seats of 5 seats. So here finally you can see the model part. So we have developed 2 models, so you can select whichever model you wanted and you can see the result of it. So let me select this gradient boost regressor for the first case, whichever I have entered, and let me click the predict button, and now you can see the predicted result page, where you can see what are all the inputs that we have given is being shown here. And finally you can see the price in euro, which is 29,791. so this is the price in euro that's been listed. So as it is a regression model, we cannot expect the same that is mentioned in the data set. So there will be some minute variations available as it is a regression model. So now we have an option of downloading this PDF. So now let me click this option and just select the desktop as 1 and let me save this. So here you can see we have an option of exporting the result whatever we got it. So that is being done here. And for predicting the other case, let me click the prediction menu again. So now what I'm going to do, I'm going to give the same data what I have given for the first case. This is to show you the difference between the result what we got in the model part. So now let me give the same values whatever I have given for the earlier one, with the same values I'm giving. So now what I'm going to change is the model part. So I'm just selecting the Extratree regressor. Earlier I selected gradient boosting regressor. This time I'm selecting Extratree regressor just to show you the difference between the model results. So let me click the predict button again. So now it will be navigated to the prediction result page, where you can see what are all the input values that we have given, and you can see the result that we got. The price in euro is 29,791 euros. So earlier the result was the same only, so we have got the same result, 29,791. So both the model gave the same result for this. So as we did for the earlier case, you can just download this and save it for your future reference in case if you need it. So now let me go to the prediction menu. This time I'll just give another brand, Tesla. I'll give model as model 3, acceleration as 4.6, top speed as 233, range in kilometers are 450, efficiency as 161, fast charging as 940, rapid charge as powertrain all wheel device AWD, unplugged type is type 2, and body style is sedan, segment is D, seats of 5. So let me select the gradient boost regressor itself and then click the predict button. So now let us see the predicted result. So here you can see the price in euro is 68,921. So now let me go to the prediction menu again. So now this time I'll just enter the brand as Nissan. So now let me select the model as ENV200 and the acceleration in second is 14, top speed is 123, range as 190, efficiency as 200, fast charge as 190, rapid charge yes, powertrain as front wheel device, plug type is type 1, and body style is SPV, segment, the segment class is N, seats of 7. So let me check the result for this. Let me click the predict button. So these are all the input values that I have given, and you can see the predicted price in euro is 32,768 euros. So now let me go to the prediction menu again to give you details of BMW i4. Acceleration is 4, top speed is 200, range is 450, efficiency is 178, fast charge is 650, rapid charge yes, power drain as RWD, plug type as type 2 CCS, body style as sedan, segment as D, seats of 5. So now let me check the predicted result for this, and here you can see the predicted price in euro is 64,000. And finally I will show you the final case with the brand Hyundai, model as Kona Electric 139, acceleration is 19.9, top speed 155, range is 255, efficiency 154, fast charge 210, rapid charge yes, power drain in front, plug style is type 2 CCS, body style is SUV, segment is B, seats is 5. So now let us check the predicted result for this case. So you can see the predicted price is 32,768 price in euro. So in this way you can check with the other cases that is given in the test or train folder. And finally move to the chart part. So here in the chart part we'll be seeing the static visualization chart. So first chart is the accuracy chart. So here you can see the accuracy chart compared with the both the gradient boosting regressor and Extratree regressor, so which contains the training set mean absolute error value and the test set mean absolute value for both the gradient boosting regressor and Extratree regressor. So this is the accuracy chart, and next chart is the distribution of the seats count chart. So here you can see the seat count, for example. So most of the data set part contains 5 seats part card only, so that is being shown here. And here you can see the powertrain type. So as I mentioned, there is 3 power type, that is all wheel drive, rear wheel drive and front wheel drive. So here you can see the count of those power type distribution chart. Next comes the plug type distribution chart. So there are 4 plug type distribution, type 2 CCS, type 2 Chardamo and type 2 and type 1. So here you can see most of the plug type contains the type 2 CCS, Next comes the body style distribution chart. So here you can see the body style like sedan, hatchback, all the SUV kinds of things. So most of the data set which we have trained contain the SUV, then comes the hatchback and the sedan part. And next chart is EV segment type count chart. So here you can see about the segment. There are various segments available. So here you can see most of this data set part contains the C segment. And here you can see about the next chart, density distribution of top speed chart. So maximum where EV has the top speed of 150 around, so that is being shown here. And here you can see the density distribution of the vehicle range. So what is the range of the kilometer, so that is being shown. And next comes the distribution of the efficiency chart. So this is the efficiency chart density. And next comes the brand count chart. So here you can see the various brands available. So most of the dataset part contains the Tesla brand vehicle. And finally density distribution of acceleration time, and finally density distribution of EV price in euros. So this is being shown here in the chart part. So this is all about the chart. The various charts, static visualization charts are available in this chart part. And now let me log out. This is all about the project electric vehicle EV price prediction using machine learning. And thank you for watching.